at Maths Form 4. Topic Vector. Lesson 1. Notes. Number 1. Vector is a quantity that has magnitude and direction. You have learned this in your Physics Form 4. Number 2. A vector can be represented by algebra as capital AB arrow or small alphabet with a curly line below. Okay? The vector represented by algebra ABCD, capital alphabet with an arrow on top or a small alphabet with a lower curly down. Next, number 3. A vector also can be represented by a diagram with a straight line and an arrow. A vector can be represented by diagram with a straight line with an arrow. Example, the straight line AB with an arrow, or straight line with an arrow, the small alphabet. Next, number 4. The magnitude of a vector AB or the small a is represented by the modulus of the vector AB or the modulus of the vector A. Okay? So vector, the magnitude of a vector, if it is capital AB arrow, you draw the modulus line, the two vertical line. If it is a small alphabet A, you also draw the capital, the modulus line with a small a. Next, a zero vector is a vector whose magnitude is 0. We usually don't use zero vector in SPM. Next, number 6. A negative vector. The negative vector of vector AB or even the small a is a vector which is parallel to the original vector and the magnitude same as the magnitude of the original vector, okay, but opposite direction with the original vector. Again, a negative vector of a vector is a vector where it must be parallel to the original vector and the magnitude same as the original vector, only the opposite direction with the original vector, and it is written as negative AB or BA. It's either written as negative AB or BA. So let me highlight this. Negative vector of a vector AB. It is a vector parallel to the original vector. The magnitude same as the original vector, but it must be in the opposite direction with the original vector. And it is written as negative AB or BA. So negative AB same as BA. You just exchange the alphabet. Okay. Next, we look at equal vectors. Equal vectors. If vector A and B are equal, vector A and B, they are equal, there are 4 conclusions. First, there are 4 conclusions. Both vectors must be parallel. The moment the vector is equal, they must be parallel, and the magnitude of both vectors must be same. Okay, this is very important. When two vectors are equal, automatic, they are parallel, automatic, their magnitude is same. Next, they will be same direction if both have same sign. That means A and B both is positive or both is negative, same direction, if they have the same sign. And they will be opposite direction if both have opposite sign. That means the A positive, B negative, or A negative, B positive. Next, we are still on equal vectors. If NA same as NB, the N and the N are numbers. The A and B are vectors. So if we have NA vector same as NB vector, whereby M and N are scalars, numbers, then again, both vectors must be parallel, but the magnitude of vector A is N over M of magnitude vector B. And how I got this? I shall write this here. If I have M vector A equals to N vector B, I transfer the N from the left hand side to the right hand side. So now I have that the vector A is N over M vector B. So the magnitude of the vector A is N over M of the magnitude of vector B. So I just put the modulus line here. Okay? I just transfer the M to the right hand side. I got vector A, N over M, vector B. Therefore, the magnitude of vector A is N over M, magnitude of vector B. And similar to just now, it will be same direction. If same sign, it will be opposite direction if opposite sign. Okay? Next, we shall look at a special case, vectors equal but not parallel. Vectors equal but not parallel. Our next thing. Two vectors are same but not parallel. Example, we are given M vector A equal N vector B. Okay, but if they are not parallel, that means the number M is 0, the N is 0. I give you a simple example. Let us say I have a simple example regarding this. I have a vector x plus 1 vector A equals to y plus 3 vector B. And we are given that the A and B are not parallel. By right, if equal, it must be parallel. Here they have given equal but not parallel. It means the number in front, the x plus 1 and the y plus 3 must be 0. So we have x plus 1 equals to 0, y plus 3 equals to 0. Of course, from here we can get the value of x and y. Okay, this is actually an example of a question. So I'm going to rub this off with just an example. We continue. Now we look at 3 points in collinear. The word collinear means straight line. Okay, I have a line with the points ABC. I have a line with the points ABC. If they are collinear on the same line, that means I take a vector AB, and then I divide by vector AC. With the common point A, up and down must have common point. It will become a number. So when 3 points are on a straight line, okay, 3 points on the straight line, take any vector, divide by another vector. This is vector divide by vector with the common point. You see AA, you'll get a number. So I can do now the first example here, it is AB and AC. AB one line, AC another line. The A is the common point. Or I also can do AB and BC, where B is the common point here now. So B is the common point. Still, I'll get a number. So the lesson is, if 3 points are collinear in a straight line, vector divide by vector with one common point, vector divide by vector with one common point, you will get a number, which I have written here. If you watch, vector divide by vector is a scalar number with one common point. So if you have vector divide by vector is a scalar with one common point, then the conclusion, the 3 points must be collinear. Next, we look at resultant vector. Resultant vector, this one also in physics. Resultant vector is a sum of vectors. Now how do we finding resultant vector? I put short form RV. Finding resultant vector, I put RV for the vectors A and B. It depends. It depends. If the vectors are parallel and same direction, okay? If the vectors are parallel and same direction, meaning vector A, vector B, parallel and same direction. Now the resultant vector, you just plus. Remember, it must be parallel and same direction. The resultant vector, just plus the two vectors. Next, if the vectors A and B are parallel but opposite direction, now the resultant vector, you minus either A minus B or B minus A. Usually bigger minus smaller. How? So the first case that I've done, number one here, which I've done, the vectors are parallel and same direction. Number two, the vectors are parallel but opposite direction. Now comes the third part. If the vectors are not parallel, A and B not parallel, example, not parallel, example. You see this vector A and this vector B. This is not parallel, but they are starting from the same point. Another one not parallel, not parallel. Here, it is ending at the same point. So when you have vectors A and B not parallel, starting from the same point or ending at the same point, we must use the method parallelogram. Use the method parallelogram. What is that method? Simple. You copy back the vector A and vector B, draw back the vector A and the vector B. Just draw back only. Just draw back. Actually, you can do it in a scale drawing. So I just draw back. And then you construct a parallelogram. You construct a parallelogram, meaning the opposite side must be parallel. And this will be parallel. Therefore, the diagonal line will be the resultant vector. I repeat. When two vectors are not parallel, starting same point, ending same point, method parallelogram. What you do, draw back the two vectors, construct a parallelogram, draw the diagonal line. The diagonal line is the resultant vector. Same goes for here, two vectors not parallel, ending at the same point. Again, draw back the vectors, construct parallelogram. Again, the diagonal line is the resultant vector. There's one last case when the vectors are not parallel, the case of one vector ends at a point. Example, if you see this, This vector A, it is ending at this point, and then vector B starting from that point. So one is ending, the other one is starting. Here, the method we are going to use is triangle method, different. All you have to do, draw the triangle back. You see the vector A I draw, the vector B I draw back. The third side is the resultant vector. The third side, this third side is the resultant vector. You start from the initial point, you end at the final point. So this is the resultant vector. Next, how about finding resultant vector when there's more than two vectors? So far, all we did was previously all this was two vectors. Only two vectors. Now, finding resultant vector when you have more than two vectors. Example, three vectors. Three, I think enough. Watch. I have a vector A plus with vector B plus with vector C. More than two vectors. The method is use polygon law. How do we use the polygon law? Complete the polygon from the starting point to the ending point. Okay? You watch, this was the vector A, this was the vector B, and this was the vector C. So the resultant vector, you start from the starting point, and then you go to the ending point. From the starting point to the ending point, this is our resultant vector. Okay? We also can do this in terms of algebra. You see, vector AB plus vector BC plus vector CD. And if you notice, this B, let me change the pen, red. Okay. This B and B can cancel. This C and C can cancel. So we are left with A and D. That's why we got this vector A and D. So the similar alphabet can cancel. And find next, subtraction of vectors. Vector minus vector. Subtraction of vector A from vector B. We are minusing A from B. Subtract vector A from B, it means B minus A. B minus A. And this vector B minus A is actually same as the vector B plus the negative vector A. So if I have a vector P minus R is actually P plus negative R. Okay? So in vectors, we don't have minus. It must be plus of the negative vector. In vector, we don't have minus. It is actually plus the negative vector. Just take note of that. Next, we look at vectors in Cartesian coordinate. Now, before we look at vectors in Cartesian coordinate, there are few terms you must know. The first one would be unit vector. The word unit means one. So unit vector is a vector whose magnitude is 1. That's all. A unit vector is a vector whose magnitude is 1. And we have two special unit vectors, the vector I and the vector j. I is the unit vector parallel to the x-axis. Give you an example. It can be like this, I. It can be like this, I. It can go in the opposite direction, it will be negative I. Go opposite direction, negative I. Basically, I is the unit vector parallel to the x-axis. It can be parallel anywhere, as long as, it can be anywhere, as long as parallel to the x-axis. Next, we have j. Again, j, unit vector parallel to y-axis. You can have. This is j. If it's going up, positive, j. If it's coming down, negative j. Coming down, negative j. As long as the vectors, all the vectors must be parallel to the y-axis. Okay, I've shown actually here, the diagram is here. Next, now we look at, this is critical, we look at vector in Cartesian coordinate can be expressed in vector I and j. Any vector in Cartesian coordinate, you can express it in the unit vector I and j. Example, to give one example, I have a vector A here. So this vector A is actually xi plus yj. You see the vector A, xi plus yj. We already know what is I and j. I, unit vector parallel to x, j, unit vector parallel to y, and the x and y are numbers. The x and y are numbers, any numbers. Now writing like this also can write in, it's like a column form. Example, if I have a vector A, 2i plus 3j, I also can write it in a column, 2 on top, 3 below. Okay, 2 integers numbers. Next, we look at position vector. The word position means the vector must start from origin. So position vector is a vector start from origin in the Cartesian coordinate. So we have a few here. The position vector OA, position vector OB, position vector OC. Now how are you going to identify all these? The first alphabet must be origin O. You see? The first alphabet must have the origin O. Must have this. Okay. Another thing regarding position vector, we can get its coordinate. Watch. For position vector OA, because starting from origin, let us say this position vector OA is xi plus yj. That means the coordinate of the point A is xy. I have given an example here. Look at the example. For the position vector OA, 2i plus 3j. That means the coordinate of A is the 2 and 3. It's the point 2 and 3. And then we can do this reverse. I said from the position vector we can get coordinate. So this is the example I did. The reverse. From the coordinate I can get the position vector. If the point A is xy, the position vector OA is xi plus yj. Again, another example. I have a point A, 4, 5. If I have the coordinate of the point A, I can get the position vector of OA, which will be 4i plus 5j. Okay, so if I have OB is 7i plus 2j, the coordinate of B is 7 and 2. So that means from position vector, I got the coordinate. Reverse, let us say I got a point B, 3 and 5. This is point. I can get the position vector OD, which will be 3i plus 5j. This is the opposite. From coordinate of point, I can get position vector. Which I have done here. Position vector OA, we can get the coordinate of A. And coordinate of A, we can get the position vector. Next, still on position vector, non-position vector can be changed to two position vector. AB is not position vector. It is not starting from 0. But AB same as OB, the second alphabet, minus OA, the first alphabet. Another example, CD, not position vector. But same as the second alphabet D, it is OD, second alphabet, minus OC, first alphabet. Okay? So if I were to give you a vector EF, not position, it is the second alphabet OF minus OE. Next, for a vector, any vector in I and J, example, the vector A is xi plus yj. Remember, x and y numbers. So if you are given a vector in ij only, only in ij, the magnitude of the vector, modulus A, Pythagoras theorem, is the square root of x squared plus y squared. This is Pythagoras theorem. And the gradient of a vector, vector got gradient because it is a straight line. The gradient of vector A is the y divided by x. Y is with the j, x with the I. Next, we look at a term called unit vector. For a vector A, xi plus yj, the unit vector for the vector A is labeled as the head A. The one you see here, I put just now. This is A. This is called a head. This is called a head. Mathematical term head. Okay, I just trying to tell you the symbol. Now you watch. So for a vector A, which is xi plus yj, the unit vector for the vector A, labeled as A hat, it is, you take the vector A, divide by the magnitude of the vector A. To find unit vector, take the vector A, divide by the magnitude of the vector. This one I have to give you example. We watch the example. I have a vector A, 3i plus 4j. I want to find the unit vector A. I take the vector A, divide by the magnitude of the vector A. Okay? So A, this vector A, I just copy back 3i plus 4j. And how do you find the magnitude? Just now we learned already. It is the square root of the 3 square plus 4 square. Of course, 3 square plus 4 square, square root, you are going to get 5, Pythagoras theorem. And then what we do, we break this up. So now this is 3 over 5i plus 4 over 5j. This is our unit vector for vector A. And finally, our notes. This is the most important notes. The most important note. In solving vector questions, finding a vector, to find a vector, you must use a line or a polygon. If you are going to find a vector, you must use a line or a polygon involving that vector. I give you an example. This one we need example. We are given a polygon O, A, B, C, and D. This is what is given. You watch. We want to find the vector AB. So if you want to find vector AB, which is over here, you must use the polygon involving the vector AB. What is the polygon? I repeat, if you want to find the vector AB, this, you must use the polygon involving the vector AB, which is what? The polygon OAB, this polygon. You must use this polygon. Another example. Let us say you want to find vector BC, which is over here. That means you must use the polygon involving the vector BC, which is OBC. Now you must use this polygon. So when I do the questions, you will get a clearer understanding. Okay, another thing before I finish. If you are given ratio of vectors, MAB same as NBC, change it to fraction, and then you must put back in the diagram. Example, if I'm given 3AB, vector AB, same as 5CD. So we have numbers 3 and 5. You must change these to fraction. So that means the vector AB divide by the vector CD. Take the 3, go the other side. It will be 5 over 3, which is 5 ratio 3. And this thing, this number, you must put back in the diagram, of the question. Okay, that's it. I'll see you on the next lesson. If you have any doubt, please see the video more than once. Thank you.